All right. So our first step is going to be to find our all possible options for our rational roots. So that's when we're going to find our factors of p and our factors of q. What is our p? 7. So what are our factors of p?
1 and 7.
1 and 7. What is our q? 1. What's factors of 1?
1.
Just 1. So our all possibles is going to be what list? Plus or minus 1 and plus or minus 7. So to test and see which ones might work, what are we going to do? Substitute them in. So we're going to do f of 1. And we're going to do f of negative 1. And we're going to do f of 7 and f of negative 7. We're going to see if any of these work. So we're going to substitute them in. And aren't we lucky ducks that we get to use calculators? 1 we don't necessarily need a calculator for, because 1 to the 4th is 1. Minus 9 times 1 plus 7. So 1 minus 9 plus 7. Negative 1. So we can tell very clearly, since this does not equal 0, 1 is not a root. When we do f of negative 1, what do we get? So we have 1 plus 9 plus 7. P is the constant at the end. Q is the leading coefficient. This guy was our P. This guy was Q. It's our leading coefficient.
Like next to the P, you said P.
Oh, the factors of.
Oh,
Things that multiply to make 7. Yeah. So when we do negative 1 to the 4th is positive 1. Negative 9 times negative 1 plus 9. So we have 1 plus 9 plus 7. We should get 17. So we know negative 1 is not a rational root. We're going to do the same thing with f of 7 and with f of negative 7 to see if either one of those is roots. What values do we get? So utilize our tools. 7 to the 4th minus 9 times 7. Ooh, make sure we're not in the exponent.
2004.
Plus 7. I am in the exponent there. Boop. Yep, we should have 2,345. So that one's very clearly not a root. Same kind of vibe with our negative 7. Make sure you are careful with your parentheses on your calculator. What do we get? 2,471. If you had a negative number there, you did not include your parentheses. You got to, especially with the negatives, negative 7 to the 4th in parentheses like this. It is really important. Otherwise, the calculator views this as negative 1 times 7 to the 4th if you don't have it in parentheses, and it will do this before it does the multiplication. So you have to put it in the parentheses if you're using it if you're doing it in the calculator. Got to. So since none of our options equal 0, this is all of our possibles. There's nothing outside of this that we could have as a rational root. So since none of these equal 0, there are no rational roots. That's how we prove it. So when it says show that it has no rational roots, you find your list of all possibles and substitute them in to find values. Show me that they don't equal 0. So we're looking for those values. So there is one in the homework like that, and it just feels like it's being super tricky, and all they want you to do is to find your all possibles and substitute them in. Okay? Because now what we're going to do is we're going to take a polynomial and we are going to find all roots. That's what we're going to do most of the time today. So, anybody need more time on this one? Boop. So we are going to find all real zeros of this polynomial here. I've got 2x cubed plus 11x squared minus 7x minus 6. Always a good idea to see if we can factor anything out and see if our life's going to be easier that way. Nah. Even factoring by grouping, I couldn't pull anything out. I don't have any GCFs or anything like that. Nothing to make my life easier. So we're going to go with what we've been working with, our finding all possible roots and using substitution to kind of look our way into one. So we're going to start with finding our list of all possibles, which means I need to know what my P is. What is the value of P? It's this guy down here. So it's going to be our 6. And what is our Q? It's our leading coefficient. This guy is Q. So our factors of 6 are what?
2, 1, 3, 6.
Yep, 2, 1, 3, and 6. I was just taking the order. I heard them. And our factors of 2 are 1 and 2. It doesn't matter what order we write these in. It genuinely doesn't. If you want to put them 1, 2, 3, 6, 6, 3, 2, 1, 1, 6, 2, 3, it does not matter. The order does not matter. It's still going to give us our same list. Because the thing we need is our all possibles, where we do our ratio between P and Q. So I'm going to take each of these terms and set them up as a ratio. So using that 2, I'm going to have my plus or minus 2 over 1. So that's just going to be 2. And we're going to have our plus or minus 2 over 2. Well, that's just 1. Then we're going to do my next piece. I'm going to use the 1 just because we gave them in an interesting order, so I'm going to use them that way. We've got our plus or minus 1 over 1. Well, I already have 1 in my table, so we don't need to put that there. Then we're going to have our 1 over 2. I don't have that one, so we need our plus or minus 1/2. Then we're going to do our 3. So we've got our plus or minus 3 over 1. That's just plus or minus 3. And we're going to do our plus or minus 3 over 2. I don't have that in my list. We're going to write it down. Plus or minus 3 over 2. One more set where we have our 6. 6 over 1, so plus or minus 6. And then 6 over 2, well, that's just 3. We already have 3 in our list. So this is all of our possible rational roots. This is our list of all possible. So instead of having to think of every single number in the entire existence of the universe, somewhere in that list would be all of our real roots, or all of our rational roots. So if we're looking for roots, we can start just plugging and chugging and guessing and checking here with these values. We can also think about our Descartes rule of signs to see if it helps us figure out which ones we might want to try for, to see if we know for sure we have one. So using our Descartes, this is our sign changes. How many positive real roots are we going to have? 1. It starts positive and it changes negative, so we only have one sign change. If we do our f of minus x to find our negatives, since my first term has an odd degree, that sign does change. So we're going to have our negative 2x cubed. My x squared, that sign will not change because it's a positive exponent. On my 7x, that sign will change because it's an odd exponent. And my minus 6 will stay constant. So how many negative roots could we have? 2 or 0. So when we're looking at trying to figure out which roots we have, I know for sure I'm going to have one positive real root. I might have 2 negative roots. I might not have any. So the Descartes helps us kind of choose when we're substituting in. You can use whichever one you want. If you want to do negatives as well, because there might be 2 of them, maybe we're lucky, it's a gamble. Because it could be that we have 2 complex roots there. Or we could have irrational roots, which we're not going to find in our list. So you can use whichever ones you want, but we're just going to kind of plug and chug and guess and check until we find a root that works. So, what value do you want to use? What do you want to try? Two? We can start with 2. So f of 2. What is the value of f of 2? Type it in your calculator. We're going to have our 2 times 2 to the third.
2 to 3.
What's up?
Oh, no. 40?
I did not get 40.
30.
Oh, I...
Oh, yeah.
You can try texting anyway.
Oh, I did too. I'm sorry.
Make sure you're using the positive f of x equation. Oh, I missed a thing. There we go. I'm going to be like, how am I that far off from you? I missed a plus sign. So I have a couple of pieces multiplying that shouldn't. Yeah, there we go, 40. Okay, so we know that 2 is not a root. So it's not going to be positive 2. We can do 1. Let's try f of 1. What do you get when you type in 1?
0.
We found a root. So 1 is a root. So what we're going to do now is we're going to divide that root out to see what we have that's left over. So I'm going to take my f of x, and we're going to divide out our root of 1. I usually use synthetic division for this because it's way easier and there's a lot less work than using long division. So make sure we're grabbing our coefficients from our original function. And I'm right at the bottom, so I'm going to move this. So just so the people in the back can see. So I'm going to come up over here. So we're taking our root of 1. What are we going to have across our synthetic division for our coefficients? Good. -7 and -6. Make sure we catch those signs. Grabbing it from our f of x. So our first term drops, and we have a 2. Add them together, we've got 13. Multiply it up is 13. Add those together, we get 6. 0. So this confirms again, for sure we saw this was a root. That remainder theorem tells us when our remainder is 0, that's a root. So what is our leftover function? 2x squared plus 13x plus 6. What this tells us is if I multiplied x minus 1 times this polynomial, we would get exactly what we had before. But we weren't just looking for the one root. We want to try and find all of our roots. So we could keep going in our list, plugging and chugging. Or we can say, does this guy factor?
No.
Yes.
Yeah. Multiplies to be 12, 2 times 6. Adds to be 13, 12 and 1. It does. I was just waiting for more people to answer it. Sometimes I just wait. Because also then sometimes you guys panic and you start changing your answers. I'm like, no, you got to stick with it. Be confident. So you can do this factoring by grouping. You can do this with the box. Just be careful. I had a lot of people try and factor GCF, like when we have an A value, just using the 12 and 1, where we had our 12 and 13, 12 and 1, and they would put it as x plus or x minus 12 and x minus 1, which that does not work. We have an A value. So you can absolutely do this with our factoring by grouping. Totally fine. Hello. There we go. My iPad's in a mood today. But either way, we're going to wind up with what factors? What are our factors going to be here for this piece? Our x minus 1 is just dropping down here. 2x plus 1 and x plus 6. So what are our roots?
Negative
1 is from this piece.
negative 6.
Negative 6 and negative 1/2.
Oh, double the negative.
So we have our 2 negative real roots and our 1 positive real root. Okay, because it's a degree of 3, so that means we needed to have our 3 roots.
That's nice.
What's that?
That's the quiz. You know how much I go for this now?
Yeah. We will have times when I give you a polynomial and I say, find all of them. And it might not just be a cube.
No, it's
Okay, we're going to practice more of these, but this is kind of what the rest of this chapter is about. Or not chapter, rest of this section is about.
yeah, can we just start with
Okay.
that's
Whoa.
So we're going to try and find all of our real roots. We've got x to the 4th plus x cubed minus 26x squared plus 4x minus 120. Hey, at least y'all get to use calculators. Last year they didn't, and it was the same exact questions. Just saying. We did a whole lot more synthetic division instead of typing into the calculator, because that was how we would do our substitution. So the first thing we want to do is see if we can find our list of all possible options. So we need our factors of p. What is our p? 120, yeah. Negative 120, positive 120. It's not a huge deal because we're doing plus or minus on both of our roots, so the sign doesn't really matter. What's our q? At least that's nice. So what we really need for our factors are for our all possible factors. Since it's over 1, we know it's just going to be our plus or minus factors of 120. I don't know what that was. So our factors of 120 are going to be what? 1 and, I was going to say, sometimes when we're doing our factors, it helps to like do it as our outside in. So we're going to have 1 and 120. Does 120 divide by 2? So 2 and 60. So 120 divided by 3.
40.
So 3 and 40. 120 divided by 4. 4 and 30. Does 120 divide by 5?
6.
5 and 24. It does, in fact, divide by 5. If it ends in a 0 or a 5, it divides by 5. It's 24. Does it divide by 6? 6 and 20. They're getting closer together. What's our next one? There's one in between. 8 and 15. And then our last one, 10 and 12. So we have a lot of options here. We have a lot of options. So let's see if we can kind of narrow things down a little bit. With our Descartes, how many positive roots are we going to have?
2, 3,
How many sign changes do we have?
1, 2, 3.
1, 2, 3. We have 3 sign changes, so we're going to have 3 or 1 positive real roots. So let's think about our f of minus x, and how would that do with our sign changes? So if we think about minus x, the even degrees aren't going to change signs. We're going to have our positive x to the 4th. The odd degrees do change signs. And remember, minus 26x squared minus 4x minus 120. So how many sign changes does our negative have? It just has 1. We've got, it starts positive, it switches to negative, and it never comes back out of the negatives. So we might have 3 positive real roots. We might have 1 positive real root. We might have 1 negative real root. So using that as kind of a guide, we can think about which ones we want to substitute in. But even still, after that, it's still kind of a guess and check situation. So pick some values. Start going. See if we can find a root. Luckily, we get to type things in the calculator. You don't have to do these by hand. So just be careful. What are you going to start with?
2 and 4.
So I've heard somebody starting with 2. I've heard somebody starting with 4. Do it. Keep going. Give me values until we find one.
120.
You going to start with 120? Go for it. Bold strategy.
You never know.
You never know. You never know. It could be 120. You can try it. Go for it. See what our values are. I have several of them. I don't have all of them done. So type them in the calculator. Be really careful. Make sure you don't wind up like just typing everything into an exponent, because especially when we have these bigger exponents, you have to be really intentional about that.
I got 2. Okay. I got 208,713,960.
So for our 120, we got a very large number.
I don't think that's
So I'm pretty sure that positive 120 is not a root, because that one came out in the millions. So we're going to go with no on that one. I'm just going to cross out the plus sign on there. We didn't check the minus, but we did check the positive.
I got negative 192
For 2, yep, I got negative 192. So we know it's not going to be a positive 2. Who was doing 4? Somebody said it. Negative 315? 360. Okay, well, No, it's not that.
Well, maybe let's do
We're just gonna kind of guess around, bounce around.
12.
You could do 12, 5.
5.
So f of 12, f of 5. We found one. We found one.
Just one the lottery.
5 has a root.
But seriously, if I didn't get the right one first try,
So we're just kind of guessing and checking on here. We have a list of options. It's better than having every number from here to infinity, but we're just kind of guessing around in here.
it's not 12.
So it's not 12. I agree. But we've got our 5. So I'm going to just cross out 12 just so we have that information there. So what we're going to do is we're going to divide out our 5 and see if that helps us do something. So I'm going to take my 5 and I'm going to do my synthetic division for this whole kit and caboodle. So we're going to take our 1, minus 26, positive 4, and minus 120. There we go. I'm squished, but I'm there. First term drops. That's definitely going to be a 1. Multiply them together. 1 times 5 is 5. 5 plus 1 is 6. 6 times 5 gives me 30. We're going to add those together. We've got 4 times 5 is 20. Add them together, we get 24. 24 times 5 is our 120. So we have our remainder of 0. Yay! So now we have this kind of leftover piece here. If I write this as a polynomial, what degree is it going to have? 3. So this is the same thing as x cubed, because our division always takes us down 1, plus 6x squared plus 4x plus 24. And we're still trying to figure out what our roots are going to be. So, option 1, we need to look and see if we can factor this, which it will, but I want us to see something else first before we go and do that. What is the new value of p? 24. So in our list of all possible options, are there some things we can say for sure are not going to happen? Again?
Yes.
So I know, since my new p is 24, definitely it can't be 60. I'm going to change to a different color so once we know that. Now that we know this. I'm going to use like a pale purple. So since my new p is 24, it can't be 60. It can't be the negative 120. We already did the positive. It can't be 40. It can't be 30, because those are not factors of 24. I'll say, what other things can't it be? 15. It can't be 10. Can't be 20. We're not going to have another root at 5. So even without having to do more work, I can eliminate a lot of my options out of here. So even if we don't notice that this could factor, we've limited our choices down to our 1, our 3, negative 2, negative 4, these guys, 6, 8, 12, and 24. So we've cut about half our options. So we don't just have to take the original list and go front to back with that. Sometimes halfway through, we get to eliminate some things out. We can also look at our leftover guy here and see if we can factor that to make our lives easier. This one will factor by grouping. Break it into our pairs. So we're going to have our x squared that comes out in the front pair to get x plus 6. And I can take out of both of these a 4 to get my x plus 6. So it does factor nicely into our x plus 6 and x squared plus 4. Also, don't forget about this guy up here, our 5. He's still a part of this. So what are our roots going to be? So this guy we know, that's our 5. That's our root. What's our root for the x plus 6? Negative 6. What about for x squared plus 4? Yeah, this is when we're going to get our imaginary answers. If I set my x squared plus 4 equal to 0 to find that root, we get our x squared equals negative 4, which means our x is plus or minus 2i. So we can still get complex roots. Our 4 roots for our quartic function, we have 5, negative 6, and plus or minus 2i. So even when we have these obnoxiously big numbers and these obnoxiously big lists, sometimes halfway through we can eliminate out big chunks of them. So yeah, they're a lot of work and they sometimes take up a lot of space, but we can do the thing. What's up? That was our guy that we found here. So when you're finding all roots, even our first one, we need that too, because I need to have 4 roots. I've got my 5, my minus 6, and my plus 2i, minus 2i. That's my 4th. We need as many roots as we have degree. Okay? Let's see, we have 10 minutes left. Let's give you guys some time to work on it on the homework and ask questions, because we've done a couple of these, gone through lots of options, and then doing one more is not going to be really very much different. We already talked about if we see the new p, what that can adjust for us, and that can help us do things and eliminate things out. Okay, so I'm going to put up here the 4.4 homework, because it doesn't get worse. Like, they don't get worse than that. So practice with them. You guys got 10 minutes. Look through stuff. If you got questions, let me know. I am happy to talk through stuff, work through stuff, whatever we need to do. And I will have for you guys tomorrow, I'll make another review for the quiz. So I'll get another one of those put together for us, and I'll get those printed out, and you can have them tomorrow. Just because I had a lot of people say that was really helpful. So yes. I will put it on my list for today, and I'll get them for you tomorrow. What's up?
A lot of questions. There's like a lot of questions.
Okay. What's up?
Okay.
Mm-hmm.
So, what I'm understanding.
Uh-huh. Yes? We're shutting off the recording.